Hi dear doctors, welcome to Micro Mahasutra, and we are starting with the today's topic discussion, that is immunodeficiency diseases and HLAs. Okay, so immunodeficiency diseases, that means that if your body is deficient of immunity, what all diseases can it lead to? Okay, and in the end we'll discuss about the HLAs, that means human leukocytic antigens. Okay, so these are the human leukocytic, that means these are the antigens on the leukocytes, right? So discussing one by one, coming on to immunodeficiency diseases, that means there is defect in one or more components of the immune system that obviously will lead to recurrent infections. Let's understand about the primary immunodeficiency diseases first. Primary immunodeficiency means these are congenital. These are congenital. Now, congenital means present since birth. Please understand this. These are present since birth, that is the meaning of what? Congenital. Now, they can be because of the genetic problems, but they might be acquired as well. Okay, we'll give the examples and you'll understand it better. For example, B cell defect, of course, that's called as humoral defect. Then we'll have T cell defect, of course, it's called as cellular defect. And then we'll discuss about the combined cell defects also. So if I talk for the B cell defect, the best example is Bruton's disease. Now B for B, okay? So B for B means Bruton's disease. And if you remember, my dear friends, the main function of B cell is to release immunoglobulins. The main function of B cells is to release immunoglobulins. So for example, there is no B cell, that means there is no gamma globulin which is going to get formed, Agammaglobulinemia. So B cells are not forming. Not forming means X and X means X. So remember, Bruton's disease is an X-linked Agammaglobulinemia. So what is happening? There is low immunoglobulins. Alright. Now this is called as what? Bruton's disease. So all the immunoglobulins are less, that's why there will be recurrent infection. But sometimes there can be only IgA deficiency. So if IgA deficiency is there, I have told you that IgA is responsible for mucosal immunity, for secretory, right? I told you na, A equals to adeno is equal to adeno is equal to gland, and gland is always responsible for secretions. So secretory antibody as well as related to mucosal antibody, it leads to recurrent mucosal infections, just like your GIT infection. Okay, coming on to T cell. So T cell, oh my god, everybody's favorite. The mnemonic is catch-22. All right, catch-22. So what is catch-22? C for there is cardiac abnormalities. Again, C is hypocalcemia. T for, okay, CA for cardiac, T for thymic aplasia. All right, so H and C for hypo. Which one? Hypocalcemia, right? And 22 means 22q11 gene is there. So this is because of DiGeorge syndrome. So can you see these both are because of the genetic issues. Okay. Then coming on to combined. So severe combined immunodeficiency means that both of these are combined. B cell and D cell, both of them are combinedly responsible. So there is absence of both B and T cells. Of course, it's going to be fatal very early. And then you have got Wiskott-Eldridge syndrome. There is a triad of thrombocytopenia, eczema and recurrent infections. There is a triad of thrombocytopenia, eczema and which one? Recurrent infection. So how to remember? So please remember Wiskott-Eldridge syndrome. So Wiskott-Eldridge syndrome can be remembered by, yeah, okay, I'll write this. Wiskott-Eldridge syndrome. So what is important in all of these things? So remember that first of all, from A you can remember eczema. From A you can remember what? Eczema is going to happen. And from this syndrome, very easy to remember, MNOPQRST. So R for what? Recurrent infection. T for what? Thrombocytopenia. And of course, syndrome is going to be there. Coming on to some defects of phagocytosis. So I think this was a part of biochemistry where we discussed phagocytosis. So what happens in phagocytosis? Whenever there is phagocytosis, there are two enzymes which are involved. One is going to be NADPH oxidase, alright, NADPH oxidase, And one more is there, that is list, we will discuss it later. But for example, your NADPH oxidase is not functioning. So, of course, the phagocytosis is not going to happen, and because there is no phagocytosis which is happening, this is called as a disease which is called as chronic granulomatous disease. You have to remember the defect is NADPH oxidase. And of course, one more thing is leukocyte adhesion deficiency. So, if your leukocyte, that means if your WBCs are not going to migrate, they are not going to adhere, and of course, what is going to happen? Yes, what is going to happen? There will be no adhesion, immunity will be decreased. So, remember that in blood vessel, there is a lot of WBCs. WBCs are increasing, but the issue is they can't adhere. That's why it is called as leukocyte adhesion defect. Impaired neutrophil migration or leukocyte adhesion defect is something which you call it as. Now, if you know that these are the leukocytes which are responsible for the separation of umbilical cord, okay. So, if you know in the small little newborns, the separation of umbilical cord happens with the help of the neutrophils only. So, because they are not migrating, there is delayed in the separation of umbilical cord. There is delayed in the separation of umbilical cord. Now, there can be some complement defects also. This we have already discussed, so I am not repeating it. Then coming on to the secondary immunodeficiencies. These are the acquired immunodeficiency. For example, HIV, AIDS. They are going to kill the CD4 T cells. That's why immunity is going to be less. For example, malignancy. So, malignancy like leukemia, like lymphoma, obviously the WBCs will be formed very high. Lymphoma, definitely the lymphocytes are going to be formed very high, but they are not, they are formed but they can't act. They are non-functional. They are not in the best of their capacities to work. Coming on to the next one, some immunosuppressive therapy like corticosteroids and everything. Obviously, your immunity is not going to be functioning very properly. And yes, in the protein calorie malnutrition. Why? Because in proteins are responsible for secretion of immunoglobulins. So, proteins. So, can you understand? Globulins, nothing else. Albumin, globulin. So, immunoglobulins are nothing but the globulin only, na? The proteins only. So, if there is protein calorie malnutrition, my dear friends, I should say there is no immunity which is going to be there. So, how to remember the examples of secondary infection? So, please remember you have got AI now, artificial intelligence, and artificial intelligence is of prime importance nowadays, prime importance. So, how to remember? I for immunodeficiency, immunosuppressive therapy, then P for protein calorie malnutrition, M for malignancy is going to be there, okay, and importance means it is for the immunity, alright. So, what is going to happen if there is immunodeficiency? Of course, the opportunistic infections, the poor response to even the vaccines, because vaccines, what we do in vaccines? Vaccines require, in vaccines we give a toxoid, for example, okay, a weak antigen, the one which is only responsible for the generation of antibodies, okay. So, now the generation of antibodies is not going to occur because the immune system is poor. Of course, there will be recurrent severe infections which are going to happen. How will you diagnose them? You have to check for the levels of immunoglobulins, the IgA, IgG, IgM. Complement assays, the functional status of complements. Of course, there are some dye based tests for the phagocytes, I have already told you. And of course, the flow cytometry to check for the markers, right. If you remember the B cell marker 19, 20, 21, CD, and then T cell marker is going to be CD3, alright, and yeah, all these cells, the NK cells are going to have CD, 50, 56, etc. These types of markers are going to be there. What is the treatment? You have to give immunity from outside, immunoglobulin replacement. Bone marrow can be transplanted so that it can start generating. Gene therapy, new genes you are going to give so that it will lead to the formation of the deficient things like, for example, the T cells, B cells, and of course antimicrobial prophylaxis, so that the microbes, when they invade, they are having the antimicrobial already inserted in them. Last part, very important part, coming on to HLA. So, remember HLA The class 1 is going to be present on all the nucleated cells, like class 1 has HLA A, B and C, alright. This is first one, and then you have got class 2 which is present on the APCs like HLA DQ, HLA-DR, most important ones. What are the associations? So let's understand one by one and I'll teach you what are important. So remember B27 very important for ankylosing spondylitis, for reactive arthritis, for psoriatic arthritis, and of course the IBD associated arthritis. So B27 remember has something to get with A. So arthritis, ankylosing spondylitis, arthritis, right? Then HLA-DR2, DR3, very important. So remember this HLA-DR2, 2 for second, 2 for what? 2 for second. So of course SLE, okay, so SS coming together, right? Similarly, multiple sclerosis is going to be there, and then you have got 𝗵𝗵 syndrome, okay. So 𝗵𝗵, so good is having D is equal to di is equal to HLA. Which HLA? HLA2. Coming on to HLA3. So what you have to understand now, remember HLA-DR3 is going to have SLE, alright, because SLE is going to have 1, 2, 3 words only. And then coming on to the other ones, the grave, all the graves are going to come in 3, alright, all the graves are going to come on to 3, like the myasthenia gravis and Graves disease. Now type 1 diabetes mellitus, please remember it is DR3 and DR4. So diabetes, so if you see type 1 diabetes mellitus, so there are 4 letters, remember. So this is going to be DR3 and DR4, both of them, okay. Coming on to rheumatoid arthritis is having the 4 in, the HLA-DR4. This is something you have to remember, and how you can remember is like this. FOUR, so R and R coming together. Rheumatoid arthritis is having 4. Then coming on to HLA-DR5, so remember 5 is called as penta. So penta, P for pernicious anemia, one thing to remember. And of course Hashimoto's thyroiditis is something which you have to learn, alright, by your own. Next is DQ2, so Q and C look very similar, like Q, if you cut Q, this becomes C. So wherever you have DQ, this for the celiac disease. Coming on to the last but not the least, if you remember, I have told you that all the grave was coming in 3. So if you join 2 3s, it becomes 8 only. So the graves are having B8 also, myasthenia gravis and Graves disease. Whereas this Addison's, okay, so Addison's you have to remember that this is going to have HLA-B8 because 1, 2, 3, 4, 5, 6, 7, 8. Addison's has got 8 words, so simple to remember that it's HLA-B8 which is responsible. My dear friends, I have tried my level best to make your immune system stronger. We are done with the immune system, and now I think you can fight your battles and win successfully. God bless you. God bless your career, and I wish a beautiful success for your journey. Thank you.